Guys, welcome back to the QST YouTube channel. Today I will be solving the Term 2 Week 10 CA quiz. Let's go for chemistry. Anyways, question 1. Which of the following are common characteristics of nuclei of the same element? So let me give an example. So let's say we have hydrogen, which has one proton or electron and has one neutron, but there is an isotope with one proton and electron but two neutrons. So the charge will always stay the same, as we can see here, because the amount of protons and electrons always stays the same and doesn't change. And then as we see here, the same number of protons, because as I said, if the number of protons are different, that can change the element entirely. Number 2. Which of the following statements are true about ion formation? Energy is released when a negative ion is formed from a neutral atom. So how can I say this? So we need for these two statements you're gonna have to memorize it, but like for the second option I have a quick explanation. So to make a positive ion, we need to remove an electron, right? Okay, and to remove the electron, there will be resistive forces taking it backwards. So, which is why we need energy to make a positive ion. Number 3. Which of the following statements is true about electrons in an isolated atom? So, look, there is this drawing which someone made of a nucleus, which I'll call N. This is like the protons, and then so let's say that we have the element here, hydrogen. Okay, we have protons here, neutrons here, and then here we have electrons which move rapidly, unlike protons and neutrons, which they don't move freely, they rotate almost. Number 4. Which of the following determines the chemical properties? Okay, so as I said for the first or second question, okay, the atomic number, as we know, is the number of protons, right? And as I said before, the number of protons is like if we add an extra proton, let's say, or remove a proton, which we can't, but if we like have two elements, one of them with one less proton, the whole characteristics will change and it's a whole new element. So yeah, which is why the atomic number is the answer. Number 5. The mass of a proton is equal to the mass of a neutron and very nearly equal to 1 AMU. The mass of an electron is way smaller than a proton or neutron, is 1 over 1840 of the mass of a proton. Number 6. The atomic diameter is the distance between two nuclei in solids, and it is found to be in the order of 10 to the power of negative 10. So here we have two particles, right? Okay, so from nucleus 1, which is here, to nucleus 2, we have radius 1 of this one, then radius 2. This whole thing is the same as a diameter, which is why the diameter is the answer. And we're gonna have to memorize that it is 10 to the power of negative 10 meters. Number 7. A stable nucleus is defined as an atom that can exist indefinitely. Number 8. What is the molar concentration of a 1 decimeter cube solution of which 0.5 mole of sodium carbonate is dissolved. So we know that C equals N over V. We have moles which is 0.5 over 1 decimeter cube, which is 1 decimeter cube, which is 0.5. Number 2. How many moles of a sodium carbonate should be dissolved in 0.1 decimeter cube of water? So we have moles is equal to, concentration is equal to moles, which is N over volume 0.1. If we cross multiply, we find out that the moles is equal to 0.05. What volume of solution should be used to dissolve 0.1 moles of sodium carbonate, knowing that the concentration of the resulting solution is 0.2 molar? So here we have the concentration is equal to the moles over volume V. So 0.2 V is equal to 0.1. V is equal to 0.5. Okay, now we have part D. So we have, first we need to find the moles, right? They gave us the concentration and the volume, which is 0.1, because here they gave us in centimeter cube, but we want it to be in decimeter cube. Okay, so now we have the moles N, and we find that the moles is 0.01. Okay, so 0.01 is equal to the molar mass. They gave us the molecular formula of Na2CO3. So 46 plus 12 plus 16 times 3, which is 48. Let me just, okay, plus 48, which will give us here at the denominator 106. Okay, and then the mass here, which will be M. We get that the mass is equal to 1.06 grams. Okay, number 9. Give the formula for the ionic compound formed from each of the following pairs of ions. So for here, we're gonna have to crisscross. So Mg2 plus and then O2 minus. We're gonna crisscross. We get Mg2 O2. But here the 2 cancels out and we get MgO. Number 2, part B. NH4 minus, NH4 plus and Cl minus. We do the same thing, but here, since we know that the ratio between the charges is 1 to 1, we just put the positive ion first and then the negative ion. So we have NH4Cl. And for here we have Ca2 plus and then N3 minus. We get Ca3N2. Okay. And then we have part D, Al3 plus and SO4 2 minus. We crisscross and we get that Al2. But here, since SO4 is one molecule, not an atom, we do SO4 3 like this in brackets. Okay, number 10. Okay, so an atom is represented by the atomic symbol. Let me draw it. X, A, Z. So Z here is the um, atomic number, which I'll call An, which is the number of protons or electrons. But we're just gonna say protons for the questions I'm gonna explain later. And then the atomic number, the atomic mass, Am, it's for protons plus and neutrons. What do you think of the handwriting? My handwriting is so bad. Anyways, so here we know that the letter A is the mass number, which is the protons and neutrons. Letter Z is the atomic number. Okay. Consider the following symbol for bromine. Fill in the blanks with the numeral to determine the number of protons, neutrons, and electrons. So here the number of protons, as I said, is the same as the atomic number, 35. Number of neutrons, all we have to do is to do the the mass number minus the atomic mass. And then the number of electrons is gonna be the same as the number of protons here, since bromine is not charged. So here in question 11 is the question I wanted to talk about. So here they said that fill in the table to determine the number of subatomic particles. Okay. So neutrons, all we need to do is to do 35 minus 17, which is 18. Protons, they gave it's the atomic mass, which is 17. And then electrons is the same as the protons plus 1, because since they said here it's Cl minus. Since you see minus, okay, let me do a table. Minus plus. This is here and here will be what we do to the number of electrons. So here we're gonna do plus and here minus. So when we see minus, let's say minus 3, we're gonna add 3 to the electrons. And if we see a charge of plus 3, we're gonna do minus 3 to the electrons. What I mean minus 3 and plus 3, we're gonna do minus 3 to the atomic mass. So as we can see here, to find the neutrons, as I said, we're gonna do 27 minus 13, which will give us 14. The number of protons is the same as just let me memorize it. Oh wait, it was the last question. The atomic number, not the atomic mass. The atomic mass is something else. So the atomic number, we're just gonna do the mass number minus the atomic number, which will give us 14. The protons is just the atomic number, 13. And then for the electrons, as I said, we know that the electrons is 13. Then we do minus 3, since the charge of aluminum is 3 plus already. So we're gonna do minus 3. The reason why we do minus when we see 3 plus, when it's 3 plus, when we see 3 plus, we know that we're taking 3 electrons away. So, which is why we do minus 3 to the atomic number. Na plus. So for the neutrons, as I've said time and time again, we're gonna do the mass number minus the atomic number, which will give us 12. For the protons, it's the same as the atomic number, and the electrons, we're just gonna do 11 minus 1. Since here we see plus, doesn't mean that we don't do minus. When we see plus or minus, it's always minus 1 or plus 1. So yeah. S2 minus. Neutrons, we're gonna do 32 minus 16, which will give us 16. The protons, we're gonna, it's here, it's the atomic number, which is 16. And then the electrons, we're gonna do 16 plus 2, because it's S2 minus, not S2 plus. It's S2 minus, so we add 2 electrons. Question number 12. The diagram below shows a representation of a set of atoms and ions. Just let me erase this. Okay. So for part A, they want the diagrams that represent atoms. Atoms are particles which have zero charge or equal protons and electrons. So here A has one proton and one electron, which means it's an atom. B has also one proton and one electron. Like when they're asking for what is an atom, we do not care about the neutrons at all. Part C is not an atom because it has one proton and 0 electrons. Same with D, it has 2 electrons and 1 proton. And then E, it has 2 protons and 2 electrons. So A, B and E are all atoms. Choose the diagram which represents a positive ion. A positive ion is an ion which has more protons than electrons, which is C. Choose the diagram which represents a negative ion. A negative ion is an ion with more electrons than protons, so it's D. Number 13. The number of protons in an atom is represented by its atomic number. The atomic number, like let's say here we have hydrogen, it's here. Okay. Locate the diagram that represents an atom with an atomic number 2. So as I said, like ions with an atom or ion, whatever, with an atomic number of 2 has only 2 protons. Like, doesn't matter of the electron, only the protons. Because here they said atom, not ion. So here it's only like the neutrally charged, like same protons and electrons. So that means that here they're asking the atomic number of 2. So the number of protons and electrons are 2. Number 14. The mass number of an element indicates the number of protons and neutrons in its atom. So as I said, the mass number is here. Locate the model that represents an atom of atomic symbol 2, 1. Okay. So here the 2 means that we have 2 protons and neutrons combined. And the 1 here means that we have 1 proton. So here we have 1 proton and we have like a total of 2 protons and neutrons. Number 15. In an experiment, 0.5 moles of CrNO3 crystals in enough water in a 100 milliliter volumetric flask fell to the calibration mark. Okay, so here they gave us the moles, and here it's really simple. All we're gonna do is multiply the moles by the concentration of the atom or the ion, which is Cr. Cr has like 1, it's only 1 chromium or chrome, whatever. 0.5 times 1, which is 0.5. Unlike nitrate, which has 3 nitrates, not 1. 0.5 times 3 is equal to 1.5. Just let me erase this. Number 16. Complete the chemical equation for the dissociation of iron 3 chloride FeCl3. So here in like the normal thing, they'll just give you FeCl3 will give you Fe3 plus 3 plus Cl minus. So now here it's really simple. We can try and balance the charges here, because if we remove the 3, you can say, okay, it will be Fe3 plus 3 plus and Cl minus. How do we make the charges the same? We just multiply Cl by 3. Number 17. Atoms have a positively charged nucleus with around which negatively charged particles called electrons move. Atoms have diameters in the order of 10 to the power of negative 10 meters. Number 18. The nucleus is positively charged because it contains positively charged particles called protons and neutral particles called neutrons. Electrons, okay, they move freely in an electron cloud. Number 19. Atoms form negative ions by gaining electrons, and atoms form positive ions by losing electrons. Look, for this question, just a tip, do not put negatively charged. Just put negative ions, positive ions. Not negatively charged or positively charged. Protons and neutrons are made up of quarks, which is something we're gonna have to memorize. Number 21. Nitrogen has 7 protons and 7 neutrons. Okay, so here they gave us nitrogen. Okay, we have nitrogen. We know that it has 7 protons and 7 neutrons. So as we know, the atomic number, which is the one at the bottom, is just the number of protons. And then the one on the top, which is the mass number, is the sum of both protons and neutrons. So 7 plus 7, which is 14. Number 22. Now the last two questions are, the last question is just a diagnostic question. Select the symbol that represents the number of nucleons of an atom in the picture below. As I said, the number of nucleons. Okay, nucleons is the number of protons plus neutrons, which is, as we said, the exact same thing as the mass number. Number 23. Crystallization is a separation technique used to extract a substance from a mixture. Okay, the type of substance that can be extracted from a mixture by using crystallization is soluble solid, which is, as an example, salt with water when we were trying to find salt. The apparatus needed for crystallization are a wire gauze, evaporating dish, Bunsen burner, and a beaker. The steps that are part of crystallization are warming the solution over a steam bath, leaving the solution overnight till all the solvent evaporates, and then make sure that, like, in the options they'll say heat the solution till all of the liquid evaporates, like here, over here, boil the mixture over a Bunsen burner till all the water evaporates, but we don't want all the water to evaporate. We need most, so we need some water left. A student is asked to calculate the number of moles and atoms in a sample of 17.6 grams of propane. First of all, we're gonna have to find the moles, so we can find. Part 1 asks for the moles, and then part 2 asks for the atoms. So to find the moles, we're gonna do 17.6 over 44, which is the total molar mass, which is 0.4. Okay, part 2. They want us to find the atoms. So first of all, to find the atoms from the moles, we need to find the uh, molecules first, which is by doing the moles times the Avogadro's number, which you have to pay attention to what they gave you. 6.02 times 10 to the 23. I don't have a calculator. Just give me a second. This will give us 2.408 times 10 to the power of 23. Okay, now to find the atoms from the molecules, all we're gonna do is do this number times the atomicity, which is 11, which will give us 2.65 or 2.648 times 10 to the 24. Number 25. A sample of O2 gas contains 9 times 10 to the power of 21 molecules. So first of all, they want us to find the moles, which we can do simply by doing 9 times 10 to the 21, all of that divided by 6 times 10 to the 23, which is 0.015. Or 1.5 times 10 to the power of negative 2. And then to find the mass, we're going to do the moles times the molar mass. The moles, as we said, is 1.5 times 10 to the power of negative 2, or 0.015 times 32, which will give us 0.48. Number 26. For this question, all we're gonna have to do is balance, which is something I cannot teach myself. Number 27. Okay, so part A, as I said for like the last question, I cannot explain, but how many moles of chlorine are needed to produce 6 moles of iron chloride? So here they said iron chloride should be 6, so we multiply the whole equation by 3. So I'm just gonna write the ratio by coefficients, like after the multiplication. It will be 6 to 9 to 6 in that order. So they want chlorine, which is second in the equation, which is, as we said, 9. Thank you guys so much for watching this video. I wish you guys the best of luck in your exams, and ma'as salama.